These are what do we call scatter plots. Hopefully, somewhere along your math career, you've plotted points, X and Y. Have we done this? Hopefully, okay. So we're going to review it, okay, but then we're going to deal with the kind of points that we get, okay? So let's look at, here's the last snowstorm, because it's completely made up, it's not necessarily the last snowstorm, okay? Lasted 6 hours, and over that time, the amount of snowfall was measured hourly, except for the 5th hour when Mr. Pierce watched the 3rd period of the Toronto Maple Leafs game, okay? So we're going to look at the table, and then we're going to take a guess at maybe what the value should be, okay? And then we're going to create a scatter plot. Okay, so what do you think? Let's write some guesses on here. What do you think? What do you think the too low of a guess would be?
3.
3 what?
3 poopies. I don't know. 3
centimeters.
3 centimeters.
3
Yeah?
centimeters. That's the one.
Okay. What else? What's too out? What else is too low?
1,
Okay, 1.
2.
Okay, without being like silly. 5. Okay. What about something? What about something too high?
100.
Okay.
4,600.
Okay. Well, that's again we're being just silly. 100 centimeters.
You're being very silly.
Okay. What else? Come on, give me some reasonable guesses. Based on the table. You're looking at the table. If you're not looking at the table, then these are silly guesses.
20.
Oh. 50. 'Cause there's
Okay, 50 seems 50's too high.
20.
Okay. Yeah, I wouldn't say 20's too high.
No, I just want to say 20.
What's a good guess?
like
30.
Good guess.
30. You think 30?
30.
I would put 30 over here in the too high column.
What? 30 total centimeters?
No. Total accumulate for every hour.
Oh.
For every
for every hour.
Yeah, you're looking at the table left to right. You're trying to fill in that gray box in the table. This gray box here, buddy.
You mean in number 5?
Number 5, yeah.
Oh.
16.
We're trying to guess what it might be.
Oh. Never mind.
16?
Mm-hmm.
You think 16 is too? I think 16 is too low.
Never mind.
Are you looking at the chart?
I am.
Total accumulation or per hour?
Per hour.
No, per hour.
I already answered the question.
Hmm?
Oh, no.
Oh, sorry, guys. You're right. It is total accumulation. Sorry. It is total. It is total.
Are you adding centimeters onto every single one of those numbers?
Am I adding centimeters onto?
Every
Yeah.
single number you put down.
Yeah, I'm adding to it. So in stage 5, you're like, how much snow's on the ground? Sorry, that's what we're asking. Sorry.
Oh, okay.
So Sean, maybe hopefully now it can't be 16 because snow just didn't melt over an hour and go back to 16, right? That's kind of what's in my head anyway. Tosef, you answered the question?
Yes.
Okay, yeah, we gotta fill in the rest here. Okay. I don't know. What's a guess? What's a good guess?
18.
It can't be less, Sean. Can't be less than the hour before. Didn't melt.
Oh.
All right. Has to be somewhere between 19 and 26, right? A best guess would be between 19 and 26.
I would say 24.
It could be. I don't know. It could. Yeah, it could be. Okay, Tosef. Oh, okay. You're just okay. All right. So here's the next point. We're gonna try and plot these points now. Okay. So here's what we got. I'm gonna do this intentionally. You guys can mark it how you choose. Okay. We've got time. Are you guys watching?
Yeah.
I've got time and hours. I'll do that in blue. Where is time on my graph? Does it go left and right or does it go up and down? Kiriana. Okay. So it's down here on the bottom. Okay. Can everybody see? What color should I use, Sean? That you can see.
Orange.
Can you see the orange versus blue?
Yeah.
Okay. Okay. That must mean the total accumulation must go on the other axis. Well, these are called axes. Does that sound familiar? There's an axis here. Is everybody good? Harry?
Yes.
Okay. This is a required skill. We're gonna have to know how to do this, okay? Everywhere I see a blue number, it has to go along the left to right axis or the horizontal, right? So, I see an hour 1, right? Where's hour 1 on my chart? Or my
First number
my
on
graph?
the bottom.
It's right here. Okay, so that takes care of it's the blue piece. Then I have to also, for that blue piece, I have an orange piece. Where's the orange piece at?
Oh,
So I have my blue piece. This is where I'm at on my blue scale. I have to go find what on my orange scale?
time in hours, or, what is it? Total accumulation,
Which is what value?
4.
Okay. So on my orange scale, I have to go find that number 4. Okay. So here, right here. 1's my blue piece, 4 is my orange piece. So then I go plot that point. Okay, we see what I'm doing? Okay. Let's go to the next one. 2 and 10. I need the blue piece. Blue piece is 10, or blue piece is 2, sorry. Right? Everybody see that? So I go find 2 on my blue piece, my horizontal. And then I gotta go find the orange piece. What's my orange piece for that one? 10. So I go find 2 on my blue piece, and then I go read off 10 on my orange piece. Everybody see where that point came from? Do you want to zoom in? Is that okay?
Yeah.
Okay. What's the next one? 3 and 13, right? So I go find 3 on the blue piece, and I gotta go find 13 on the orange one. So 3 and 13. What's the problem though? Do I see 13? Kiriana. Okay, okay, good. So this axis here, or the orange axis, is counting by 2s. What's that mean? Everywhere in between is the in between. Okay, so we're counting by 2s. So you're gonna have to have a half box here on the orange one, right here. 3 and 13. Here's 13 right here. Do we see that? 13. So I go on 3 and 13. Be exactly halfway. Okay. Let's go 4 and 19. Again, we're halfway because there's 19, right? Okay. And then we don't know what 5 is, but let's go 6 and 26. 6 and 26 is up here. Okay. We could take a guess. We could take a really good guess now if we look at the pattern that's there, right? Let's just take a look here. Let's just take a look between all these dots here. I'll just draw something on here. What would be like a good pattern? If I like started down here, it obviously like it started snowing at some point in time, right?
Yeah.
So there was no snow on the ground. So we could say we start at 0, right? And then I'm just gonna draw like kind of a just a shape here. What do you think? That's pretty good, eh? So let's take a guess as to how much snow fell after 5 hours. Where's 5 hours? 5 hours is on the blue, right?
I put 23.
All right, we take a guess. Let's just see. I'm on 5 here. I'll change the color. Sean, what's a good color for you, buddy?
Green.
You can see the green?
Yeah.
So there's 5. I'm gonna read up, right? Everybody can see why I'm picking 5? Because my blue piece is 5. So I'm gonna go all the way up. Where do I crash into this kind of shape that I drew? 22. Let's go with that one. That's maybe what I should put in that gray box is 22. Can we see that, or is the green not good? Green's not good on what? What? Yeah, you can count a pattern too, buddy. We'll do that later. Okay, this is kind of a, we're just looking for a general pattern. Is everybody okay?
I don't know.
Oh, I don't know. Do we have any issues plotting the orange versus blue piece or blue versus orange?
No.
That's okay, eh? Okay, I wasn't sure. I don't know what, again, with COVID, I don't know how much math you guys did last year. All right, so I don't know what you've actually done. Okay,
A lot of people just didn't do online.
that's what I'm figuring, right? And that's a commonality. A lot of people just didn't do stuff. It's not just you guys in grade 8, it's kids in grade 9 coming to my grade 10 class just didn't do stuff in grade 9. So then we got to patch all those holes. This would be an example of a hole where people like maybe can't graph to a point, an X and a Y piece, or a blue and orange piece, right? Some people can't do that, so that's why we did it, okay? So if we come down here, there's some text here, okay? So time is what we call the independent variable. Do we know why we call it the independent variable? What's the word independent mean?
Alone,
Uh,
on its own, continuing by itself.
continuing by itself is not
Can't
bad.
do things autonomously.
True. Okay, continuing by itself is not bad. Oh boy. Continuing. Does that look right? I don't know. Okay. So it continues by itself, right, Harry?
Yes,
What that means is it doesn't change with time.
yes.
Okay, that's like
Time doesn't change.
that's a nice description. So independent, we can say doesn't change. Doesn't change. We'll just leave it as doesn't change. Okay.
Doesn't change at all. On a graph, it'll be linear always.
Yeah,
It's
yeah.
not gonna go, oh, I'm 45 and then I'm 52.
Or okay, here's the other way. Doesn't change, or can we use the word constant?
Yeah.
Okay.
It is indeed constant.
Now, why does the total accumulation of depend on time and not the other way around? Because that's the second part of this question here, right?
Because time is constant and something else can be.
Time doesn't change, right? I could sit here and do nothing, time still goes on. Or I could choose to do stuff and it doesn't matter, right? Time just continues to go on. The snow changes, right? Does that make sense? So that's what they've done here. Okay, can everybody see? If you turn the page over, did you guys have to turn your page over onto the back to see those questions? Okay, so go back on the bottom of on the other page there, on your graph. That's why they've labeled those two things. One's independent and one's dependent. Do I ever change the order of these two things?
No.
Do I put the dependent down here and the independent up here?
No.
No. The independent one always goes along the horizontal axis, or what we call the x-axis, left to right. Okay? The dependent one goes on the y, or like the vertical one, the orange. Is that okay? So, let's describe what's going on here and classify the relationship, I suppose, between total snow accumulation and time. Is it increasing or decreasing, the amount of snow, as time goes on? It's increasing. Okay, so that's good. So as time increases, the accumulation increases. So you can just circle it. Is it rising or falling to the right?
Rising.
Good. Okay, it's rising, right? Because it's going up.
Rising. Strong.
Is it strong or weak? We didn't really talk about this yet. Do you think it's strong or weak?
Strong.
Why?
I don't know. It's continuing on. It's not fading out. Like it's a linear.
Okay, sure. I think what it's talking. Okay, let's go back and look. Strong or yeah, carry on.
Maybe it's like it's basically going up. It's not like going up and then dropping drastically.
So you guys are saying something like this, eh? If there was more dots over here and it was dropping off,
Yeah.
that's not necessarily what it's talking about. Okay, what it's talking about. If you guys had to take a guess, or like just visually, Do you think this purple line I drew is pretty close to the dots?
Yeah.
I would say that is true and that it represents a strong relationship because the dots are really close to that line I drew. Right? What if I just drew a bunch of random dots in red like this? Is that as strong?
No.
Is it still increasing up and to the right?
Yeah.
It is, but it's not as strong because the dots aren't close to that purple line that I drew.
Oh, it's strong then.
Okay, so if I go back down here, it's strong.
I'm assuming it's positive as well.
It is, yeah, we'll talk about why it's positive later, but it is positive.
Extrapolation. Interpolation.
Okay? Can everybody see, have you heard these two words before? Interpolation and extrapolation?
Yes.
What do they mean, Harry? Do you know?
Extrapolation is like, given the stuff you have, you would extrapolate like the amount per hour. I don't know.
Okay, kind of, yeah.
Basically like an educated guess.
It's an educated guess, but there's a fine detail with it. It's an educated guess outside of the table of values. So for instance, an extrapolation would be if it continued to fall, like how much snow would there be at 15 hours of snowfall? That's an extrapolation, right? Okay, so let's using that, let's just run through 3 and 4 here. Use the graph of the relationship to predict how much snow would have fallen after 5 hours. Let's go back. Is 5 hours fit? Does it fit on our table?
Yes.
It is. It's right here, right? Is that interpolation or extrapolation?
Interpolation.
It's inter because 5 is in my table.
Indeed it is.
Okay, what value did we say for 5?
I said 23.
Okay, that's fine. We could say, let's go, we'll write it up here, 23 centimeters. Don't forget your units.
You said to make this?
Now, we said interpolation because
It's inside of the graph.
inside your data points from your table.
Indeed it is.
Okay? Use the graph of the relationship to predict how much snow would have fallen after 10 hours. Let's go back to our graph. Okay, this is number 4 now. Does anybody have any questions with interpolation?
No.
I hope not. It's okay though. Does anybody have any questions? No? We're okay? It's just, this is interpolation. If I could ask you about 3.5, you could answer that too, because that's inside of your data. Inside. Okay? Outside, extra. That's kind of how I would remember it. Okay? Is 10 inside my data? No, it's like way down here, right? So what are we going to classify that as? Extrapolation. Where's 10? I'm going to continue this purple line here and take a guess as to how much snow would have fallen after 10 hours.
10 hours is on.
It's on the axis, on the blue axis.
So wouldn't that be interpolation?
No, because it's not in the table.
What do you mean?
Like 10's not in the table. It just happens to be on, like my data stops here, right?
Yeah.
I don't have any more data past this point.
Oh, yeah, that makes
So anything past it is extrapolation.
Oh, yeah, past 6 is extrapolation. Yep, that makes sense.
Okay, so let's take a really good guess from the purple line. So I'm going to stand here at 10, and I'm going to look up until I hit the purple line. What value do you think you get to on the purple line? If you had to take a guess. 50, you think? That's not a bad guess. That's not a bad guess. Can everybody see why we said 50? Or why Kendra said 50? Oh, I'm moving the line around here. If I draw like another line over here, this is approximately 50, I would say. Could even be 55, Kendra. Just purely based on the line that I drew. So let's go ahead and say 55 centimeters. Interpolation or extrapolation?
Extrapolation.
Okay. Does anybody have any questions? We kind of did that quick, but
Are we doing
Yeah, I'm gonna give you a sheet to plug away at with this sort of stuff.
Nap time?
Huh?
Nap time?
Yeah, we could do till 2:15 or so. You guys want?
Nap time until 2:15?
No, you gotta do some questions till 2:15.
Hmm.
So are we okay?
No.
Too bad. Okay, all up.